So we mentioned the length field. We talked about using new to create it to say how much space to set aside. Each element in the array is its own variable, has its own name. We just use the subscripts, the square braces to index into it. Here's what I mentioned before. If the array is of type primitive, like this float array, then the values that are going to be inside that array by default are going to be for float, 0.0f. If the array is object references like string, then the default is going to be null unless you use that new keyword like we saw to go ahead and initialize it in some way. And actually, this is getting a little ahead here. We don't have to use new. You can. With string, you don't have to use new. So remember, you could say new string Saturday, and that works, or you could just do quotes and say Friday. String allows you to do it either way. We're going to see there's other stuff that are going to be object references later where the new is required. String is really the only special one where you can get away with not using new to allocate memory. As I mentioned, you use square braces to index in, and we number them from 0. Oh, here's a key thing. If you go past the end of the array, it's going to throw an exception. So if I try to say days sub 7 equals whatever, equals x, it's going to actually fail at that point. I'll need my semicolon. And the failure is going to be a runtime failure. When I run, it's going to say, hey, you can't go to element number 7. It doesn't exist. It's 0 through 6. That's different from other languages. Other programming languages allow you to index past the boundary of the array. Java is very safe about this. You can't get into memory that doesn't belong to you. And so it keeps you from going past the edge of the array. And finally, you can have arrays of arrays. If you want a multi-dimensional array, it's just an array that stores an array inside of it. And we'll see an example of that later when we look at our loops chapter. Over on the examples here, we've got several of them. We've got echo.java. Echo.java, this simply takes whatever's passed into arg0 and displays it. And so if I do a quick run configurations on echo.java, so on echo, I can type in name here, Jamie, and run it, and it echoes back whatever's in arg0. Yes, we're using an array, but we're not creating it ourselves. We're not going through the steps to say new string array or anything like that. Java does that for us, and it populates it with, in this case, my name is the element in arg0. So with our command line arguments, you index into it. You can access the values of the array, but you don't build it manually. That's done behind the scenes for you. Another example, last1.java. If you wanted to display the final element in an array, you can always do this trick. You can take the length of the array and subtract 1 from there. So, for example, the days array, length is going to give me back 7. And to show that, we'll go ahead and print out sysout days dot. I type in the letter L, push Control space, it fills it in for me, it knows what else is available, and 7. Well, if I did length minus 1, that would give me back 6, and 6 is the final index that we can use to get into the array. So if I were to run last1.java, I could do a run configurations on that, build a new configuration for last one. 1, 2, 3, 4. Run this. And the last element, arg sub 3, is going to have embedded in it FOUR. Space separate when you do command line args. And then the final example, array init.java. This one shows more like what I did with days here. We have an array called evens. It's going to store 5 integers in it, and we load it up 0 through 4 with values. We also have, oh, this is cool, there's an alternate syntax. So when working with arrays, there's 2 ways you can do this. We can do odds array here, and notice rather than having, how many lines of code? 6 lines of code here. We're doing it all in one. So special syntax in Java, you can throw in a set of curly braces and comma separate the values that you want to load into the array. And this like squishes together all those lines above into just one line. And so the odds array is implicitly going to be of size 5 because we provided 5 values. And an element 0 is going to have 1 in it. Element 1 will have 3, element 2 will have 5, etc. And finally, this is something we'll see more in a later chapter, in a couple chapters. But if you wanted to loop through an array, we can always use that length to determine when to stop. So we'll start at 0, and we'll keep going as long as I is less than the length. And each time through the loop, we'll add 1 to I equals I plus 1, printing out whatever stored in even sub I and odd sub I. This would be a great one to use the debugger for. So I encourage you to go ahead and maybe double-click, drop a breakpoint in this loop, run the debugger on your system, kind of step through, maybe look inside the array, see what's stored in each one, get a good feel for how these are laid out.